Hi class, homework 8.2. This first question is just helping you type in the thing. Type the nth root by choosing, and then I think it'll give you, it'll give you like a shadow, 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 and then here you would type in the 5 and then the 3. In this case, we start here, we have a shadow, and then we have to hit next the fraction key, and then we can fill in our bits. 5/3. So here, so my first step that I want to do with both of these is put in my implied 2. And I need to factor 63, and that is 7 times 9, and 9 is 3 times 3. So I have the square root of 7 times 3 times 3, and squared, so I'm taking out pairs. The 7 is being left by itself, so I have to just ignore it. So I'm left with 3. That was a 3 we pulled out. And look, I wrote it 2. 3. 3 square root 7. The 16, so one strategy, when they give you a variable here or something with a power, if I'm needing 2, I would sort of rewrite this as 16 is 4 times 4, and then b to the 11th is b to the 10th times b to the 1, because I know 10 is divisible by 2. And here I'm looking for divisible by 2, so I'm going to split 10, can be 5 plus 5. So I'm going to rewrite this one more time as 4 times 4, b to the 5th times b to the 5th times b to the 1. And now I'm ready to collect. There's 2 of these b to the 5ths, so I pull out a b to the 5th, and I'm left with just that one b to the 1. And so this becomes 4b to the 5th times the square root of the single b. If you wanted to go with fractional powers, we could have done that as well. I could use 16 is 2 to the 4th, and we have b to the 11th. And I realize this is the one instance where going to mix numbers is useful. Remember, I've told you before, I hate mixed numbered fractions, but here's the one case where they're useful. Anyway, so I have my square root of 2 to the 4th, 2 to the 11th, and that equals 2 to the 4th, b to the 11th to the 1/2 power. And I get 4 times 1/2, and that equals 2, and then I have 11 times 1/2. So I have 2 squared times b to the 11 halves. Now this is where we want to convert. This 11 halves is 5 and 1/2. So this becomes, and this guy is equal to 4. So we have 4 b to the 5th, and then we have a b to the 1/2 left over. I haven't checked whether or not MyOpenMath will accept this answer or not. I'll let you know by the beginning of class, but I imagine they still want, with this 1/2, is to go back to the square root power. But that's technically correct. But again, because of the auto grading, I don't know what MyOpenMath is going to do yet. Again, we have a square root. 810 is 9 squared times 10. And this is 2 times 5. So I see this as square root of 9 times 9 times 2 times 5 times b to b to the 1, and then I have b to the 5th, b to the 5th. So remember, this is now all b to the 11th. And I'm looking for pairs. So here's a pair of b to the 5ths. And here's a pair of 9s. These are all the leftovers. So this becomes 9b to the 5th times the square root of 2 times 5 times b. 9b to the 5th square root of 10b. Again, we're dealing with a square root. 80 is 8 times 10. And this is 2 to the 3rd, 2 times 5. So I am now dealing with square root of 2. So this means I have 4 of them. Times 2 times 2 times 2 times 5. Now this is the 19. So this becomes 1 plus 18. Since I'm dealing with squared, I'm going to divide this by 2 and get a 9. So 2 times 9. So this becomes b to the 1 times b to the 9th times b to the 9th. So this is b to the 19th. It's a square root, so I'm looking for pairs. There's a pair. Here's another pair. Here's a pair. So I have 2 times 2. I have 4 b to the 9th. And what's left is I have a 5 and a b. $18.75. I know 25 goes into it. Oh, I actually have a calculator. I did it by hand last time, and then I realized I needed to do the homework. So 1875 divided by 25, and I get 75. So I have 75 times 25, and 75 is 3 times 25 times 25. I mean, I could go further, and this is 5 times 5 times 5 times 5. So I could go, actually, I do, since this is a cube root. I don't have any triples yet, so I'm going to go down to the next level. So this, we need a cube root of, we have 3 times 5 times 5, 4 of them. And we have 4 x's, 1, 2, 3, 4. So because of cube roots, maybe I'll go blue, cube, you want triples. So 1, 2, 3. And this gets, and we take 3 of them, but we pull out just 1 of them because they're the same. And now I have 1, 2, 3. So I'll pull out these 3 and I pull out an x. So this becomes 5 times x, which is 5x. We're dealing with a cube root, and what I'm left with is a 3 times 5 and an x. 3 times 5 times x. So this is 5x times the cube root of 15x. That's what it simplifies down to. If you wanted to go with powers, we could have said this is 3 times 5 to the 4th, x to the 4th, all to the 1/3. And we would have gotten 3 to the 1/3, 5 to the 4/3, x to the 4/3. And we'd work with 4/3 as 1 and 1/3, 1 and 1/3. So this is 5 to the 1, x to the 1, 3 to the 1/3, 5 to the 1/3, x to the 1/3. Since these are all 1/3, we can see this is 5x times 3 times 5 times x to the 1/3, or cube root of that, 15x. (224). 4 goes into 224. Let me see how many times is 4. 224 divided by 4 is 56. So I have 4 times 56. 56 is 8 times 7. Oh, so we have 4 times 8 times 7. 4. So this is 2 squared, 2 cubed, and then a 7. So I am now dealing with a fourth root of 5 2's, 3, 4, 5, a 7, and 4 y's. 1, 2, 3, 4. Okay. So we're dealing with a fourth root, so we need 4 tuples. G-O-U-P-L-E-S. 1, 2, 3, 4. So I'm looking for groups of 4. And I pull out 1, 2. Single, 1, 2, 3, 4. I pull out all of these guys, and a y. So we pulled out the 2, the y. We're still left with this fourth root and just a 2 times 7. Fourth root of 14. Again, we'll see whether or not we have to re-multiply things out in MyOpenMath. So remember to add in the fact that this is a square root, so we're looking for pairs. 49 happens to be 7 squared. C to the 15th happens to be c to the 14 plus 1, and x to the 7th happens to be x to the 6 plus 1. So I'm trying to just pull out my even numbers, and then c to the 14th, that is c to the 7th squared, and x to the 6th is x to the 3rd squared, then times c to the 1 times 7 squared. So we are dealing with the square root of 7 times 7, c to the 7th times c to the 7th times c to the 1, and then we have x to the 3rd, x to the 3rd times x to the 1. Taking square roots, this is pairs. 7 and a 7. C to the 7th, c to the 7th. And then we have an x to the 3rd, x to the 3rd. And pull out an x to the 3rd. And my leftover is the c and the x. So I have my 7, c to the 7th, x to the 3rd, times the square root of cx. With fractions, we still just kind of keep the fraction going. 64 is 8 squared, a to the 7th. So we already know the 7 was 3 plus 3 plus 1. So this is a to the 3rd, a to the 3rd, a to the 1. 20 is just equal to 10 plus 10. So this will be c to the 20th, no, c to the 10th, c to the 10th. So I'm dealing with my square root of 8 times 8, a cubed, a to the 1, all over c to the 10th, c to the 10th. Because it's square, we're pulling out pairs. So we have 2a. We have 2a to the 3rds. And we have 2c to the 10ths. And we're just left with a single a here. That was our only odd power. So this, we have and the c to the 10th is down here. So we have 8a cubed over c to the 10th times the square root of little a. If you want it over 1, because there's still a fraction there, you can do that. If you were doing this with powers, 64 is 2 to the 6th power. So you could have gone 2 to the 6th, a to the 7th, c to the 20th, all to the 1/2. And we get 2 to the 6 over 2, a to the 7 over 2, and c to the 20 over 2, distributing the 1/2. And these guys, this 6 over 2 happens to be 3, 20 over 2 happens to be 10. So those are inclined numbers. 7/2 happen to be 3 and 1/2. So we have that this equals 2 to the 3rd, a to the 3rd times a to the 1/2, all over c to the 10th. So these are all the whole number powers. So we get 2 to the 3rd is 8a cubed over c to the 10th. And then this a to the 1/2 is square root of a. So we end up still with the same answer, but that's how you would do it with powers. So there's a square root here. 75 is 3 times 5 times 5. So my first thing, I'd write this as square root, and 15 is 14 plus 1, which is 7 plus 7 plus 1. And 18 is 9 plus 9. So my square root, I have 3 times 5 times 5 times a to the 7th times a to the 7th times a to the 1, all over x to the 9th times x to the 9th. So in our analyzing square roots, we're pulling out pairs. I can pull out a 5, and I can pull out this a to the 7th, and then I can also pull out an x to the 9th, and that's in the denominator, so I have to remember that one. And I'm left with, undo. I'm left with the 3 and the a inside. So pulling out, I have this 5a to the 7th over x to the 9th times square root of 3a to the 1. And technically, it's over 1. If 72 happens to be 8 times 9, which is 2 to the 3rd times 3 squared, and this is a square root, so 22 happens to be 11 plus 11, 2 happens to be 1 plus 1, 12 happens to be 6 plus 6, and this will be 3 b's. So I am going to write this as, and then b to the 11th, b to the 11th, x to the 1, x to the 1, all over. B x to the 6, x to the 6. Okay. Oh, I need my square root. Pairs. I can pull out 2 to the 2. I have 2 3s. I have 2 of these b to the 11ths, and I have 2 of these x to the 1s. And then down here, I have 2 1s, and I can pull out an x to the 6th. But I am left with something in the denominator. So I've pulled out a 2 times 3 times b to the 11th times x to the 1 all over b to the 1, x to the 6th. And I'm left with the 2 here and the b. So I'm left with 2 over b. Now here, I can notice I have some same bases. So I'm going to move this one up and subtract 1. So this is now canceled out. And I'm going to move this one down. So I'll subtract 1, and then this guy's canceled out. So this simplifies to 2 times 3 is, 6. We have b to the 10th all over x to the 5th times 2 over b. So this next one, I'm going to first simplify this. So I'm going to, no, I got to go green for, I'm going to first reduce this. So I'm going to move this 3 up and subtract 3, and move this 3 down and subtract 3. So this becomes 45 happens to be 5 times 9, which is 3 times 3. So we have 5 times 3 times 3, x to the 19, x to the 19th, because 22 minus 3 is 19, all over c to the 10th. And we're taking of that. So I'm looking for pairs. 19 is 18 plus 1, and 18 is my even number, so that's 9 plus 9, and we still have the plus 1. 10 is just 5 plus 5. So I have my square root of 5 times 3 times 3, x to the 9th, x to the 9th, x to the 1, all over c to the 5th, c to the 5th. So I have 2 3s, 2x to the 9ths, and down below I have 2c to the 5ths. And I'm left with the 5 and the x. So this becomes 3x to the 9th over c to the 5th times square root of 5x. Ooh! Notice here, cubed, triples. I can already see, getting ready for this, 5 is 1 plus 1 plus 1 plus 2. So there's a triple. Oh, wait, hold on. I think the first thing we'll do is bring this up, minus 2. Bring this up, minus 2. 24 is 3 times 8. 81 is 3 times 27. So I'm going to cancel out those 3's. So the first thing I'm doing is reducing this. And I'm left with 8 times y to the 21, a to the 3rd, all over 27. Now, 8 is 2 times 2 times 2. Now I'm dealing with triples. So 21 happens to be 7 plus 7 plus 7, or 7 times 3. So I have y to the 7th, y to the 7th, y to the 7th. And 3 is just 1 plus 1 plus 1. And we have a times a times a, and all over 27, which happens to be 3 cubed. So we're looking for triples. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And down the bottom, 1, 2, 3. So this one, there's no leftovers. So just reduces to, we have a 2 times y to the 7th times a to the 1 all over 3. When we have a square root over a square root, you can bring that into one single square root. I mean, these are both, first of all, make sure they're both square roots. And if they are, you can bring it into a fractional square root. This is 12 times 12. 21 is 10 plus 10 plus 1. Y cubed. And then just this would be 16 plus 1, so this is 8 plus 8 plus 1. But let's see, once we make it into one fraction, if we need to do that. So 144, we have 144 times c to the 21 y cubed over 3 times c squared y to the 17th. So I'm going to move this 2 up and then move this 3 down. And this becomes the square root of, we have 12 times 12 times c to the 19th. And here we have y to the 14th. So 14 is 7 plus 7. 19 is the 9 plus 9 plus 1. So we have c to the 9th, c to the 9th, c to the 1, all over 3, y to the 7th, y to the 7th. Again, 2's, we're looking for groups of things. So we can pull out a 12. We have 2 of these c to the 9ths. And we have 2 of these y to the 7ths. We have leftover. So we have this 12 c to the 9th all over y to the 7th times square root of, we have this c over the 3.